Thank you. Thank you very much. I am here representing today ESI Group, IC.IDO, and we are very strangely for this audience, we're not into arts and creative sciences and stuff like that. We are coming from an engineering sensibility, and our primary use case is for our customers to be able to address engineering workflows. Just rolling back in time, give you guys some context, right? Back in the early days of product development, back in the day, it was a very linear workflow. People would come up with some sort of artistic concept for a product. They would come up with some sort of geometry, maybe based on a scale model. You can see the clay model in the end over there. You can see people drawing on paper and pen, working on boards. And then at some point, they would build a practical thing. They build their first real product. And quite often in doing so, when you build a real product, you find out things like, I can't put it together the way I meant to. I can't assemble the car or build the car in a realistic manner. And because back in the day, at every one of these little milestones in the development process, we were always building practical and physical prototypes. We could realize and find things out by accident that maybe the thing that we wanted to build, the thing we were designing in theory, wasn't good in practice. And it was only rolling back the clock a couple months to redraw or redesign the thing that we were working on to do it again. Now, in comes, computer-aided engineering, right? The very early computer-aided engineering with Sutherland there, early days of AutoCAD, and everyone's so proud today when we talk to these digital engineering folks how we've done away with the need for physical prototypes, right? It's a great thing that when we work completely in digital models that we don't have to have physical prototypes anymore. I don't build a practical constructed prototype anymore. But then that means I don't have those opportunities to discover again how that physical object gets put together and maybe recognize those things that I didn't know I had to look for in putting it together. So what we try to do with IC.IDO is we want to create a virtual yet physically reliable, physically repeatable, kind of real-to-life, true-to-life visualization, and not just visualization, an experience where I can experience my physical product that I'm engineering and designing today without having access to that constructed prototype, because I've totally compressed that engineering timeline and I've taken away all those normal physical build points that existed. So we introduced IC.IDO to be an opportunity for you to be able to get back into digital engineering and access the stuff that you don't have access to anymore, which is a physically reliable, something you can touch and feel and see how it looks and see how it accesses in real life, right? Over here you can see one of our customers, they are still in the practice of doing this. That is cardboard, tubular metal prototype of a manufacturing cell that they would be engineering for their customers. Here you can see the clay models. All the people who work in styling and design visualization will talk about how they've done away with the clays. But there's certain things in those physical models that we can discover that you normally can't discover just purely on a 2D flat projection. And so what we offer is IC.IDO, that is our product, and that lets you see and do things in a physically responsive, physically realistic world so that you can understand what it's like to touch and feel and assemble, disassemble, and service your products, but working only on digital models. All right, so these are just a couple examples of the way that our customers are using virtual reality. A lot of these examples you see here are projected virtual reality using active stereo, but certainly can be done in a more modern sense of a head-mounted display as well. But you can see here people are doing kind of engineering reviews, styling reviews of new cars. Here we in the top corner we have someone doing an assemblability, accessibility review. We have a full-scale review of an engine turbine, and in this case we have our customers at Bombardier Rail for the first time being able to look at a real full-scale digital model of their train, which normally they can't even look at full all together in the native CAD format that they're normally drawing it in. And by bringing it into our environment as accelerated and powered by NVIDIA technology, they can now look at entire trains all at once in VR, whether that's projected VR as shown here or under an HMD. Right, so just giving you a little bit of the history and progression. This is a slide that I've just completely ripped off of my customer that they made a presentation at GTC Silicon Valley, and they were talking about how they wanted to look at and visualize their entire product line. And you can see here the size of the products. These are the real CAD bodies, and taking all those CAD bodies, they want to visualize them in VR. But take a look at those polygon counts, right? We're talking about for the smallest tractor that they're going to sell or engineer, that's 42,000 CAD bodies, and that's 29 million polygons. When we go to the largest in their suite and we look at all of them at the same time, we're now talking about 370,000 CAD bodies and 260 million polygons. So at GTC Silicon Valley, we talked about the performance, how IC.IDO performance has worked very closely with DevTech from NVIDIA to make sure that we were able to properly leverage every time new graphics architecture came up, that we were able to leverage all of that to see more and more performance from the graphics cards. So at SIGGRAPH last year, I made a presentation similarly talking about how we were able to, with innovations from NVIDIA, be able to look at this entire passenger train. This entire passenger train, that's 2 locomotives and 2 passenger cars in between. We're talking about right there 155 million triangles, 200,000 CAD bodies. And when we go back, I don't know, let's see, the K6000, that was our version 10.2, so that's 3 years ago for our software evolution. The frame rate that we would have had if we loaded that full model into VR is about 2 frames per second. And we would have had to reduce that model down to about only 2% of the CAD bodies in order to get a reasonable frame rate to look at it in an HMD. So I could only look at maybe the front windscreen of the train, right? But I don't sell entire trains by looking at the front windscreen only. Now, along comes VRSLI with, oh no, I jumped right over here, NV Pro Pipeline with the Maxwell. Now we're able to, by using the Maxwell acceleration, we're able to see about 13 frames per second when we load the full model, or reduce that down to 15% of the entire train. Then along comes VRSLI. When we leverage VRSLI, we could see a quarter of the train now. That's almost an entire locomotive, but not quite. You know, where are the people going to ride? And finally, we were able to, at SIGGRAPH last year, talk about how we were using the new occlusion culling algorithm and the new Pascal architecture to be able to see 94 frames per second in stereo of the entire train model. Right? And as I mentioned, our customer told us she'd never seen the whole train before all at once, except in person or occasionally as a screen grab of something that she had to let kind of accumulate over time, let the model build up over several minutes. Take one screen grab and that's your only picture. Most recently, we talked about this at the GTC in Silicon Valley. Now with the Volta architecture and VRSLI and NVLink, we were able to get 90 frames per second, but we were able to do so with an extra 146% performance improvement, which meant I could actually see an extra additional half of a train. So if we were looking at a passenger train now that had, instead of 2 locomotives, 2 passenger cars, we could actually have 4 passenger cars in between those 2 locomotives, visualized in VR with stunning performance. Now, our focus at ESI IC.IDO is not just looking at or visualizing the engineering models. What we're really focused on is this idea of human-centric product development and process validation. We want to really experience not just looking at the train, but actively participating with the train. I want to open and close the access panels to the mechanical guts of the train. I need to see if a maintenance worker can really see inside of that service hatch in order to access a thing that they might have to replace or update in their machine. So other things that we've been doing, and this again is enabled by our customers being able to use the full CAD model. This is using hand and finger tracking. We've implemented the use of Manus VR gloves and also ART finger tracking so that you can do real life hand and finger manipulation and also accessibility and reach of your forearm and possibly even your upper arm to make sure that can I see into that access panel to unplug the wiring harness and then also take out that little clip that's going to secure the tail lamp into position. And this is a common thing that our customers might tend to overlook in the engineering or the design step. Somebody will say, it looks like I can reach in there, it seems like I can, but in fact, it is a bit of a reach, it is a bit of a trick to get your hand in there. And can an average person's hand, or even a larger than average person's hand, still be able to fit in there? Other things that we've done is we've integrated digital human models. In this case, we've integrated the Ramsys digital human so that we can do true-to-life ergonomics assessments. In this case, we can. We could take a animated motion of operating or disconnecting that exhaust pipe or operating that lift assist mechanism for that spare tire, and we can play back that animated event with different size, different anthropometric models so that we can capture the full population of your potential workforce. And this allows us to use VR to experience what it's like to assemble or service or maintain your new product. But then I can take that first-person perspective, right? It only takes me about a minute to decide I don't like working over my head like that, or I don't like moving this mechanism around, it's uncomfortable. But then I still have to create the data that supports that decision of maybe redesigning the product or redesigning the tool. And this way I can just take my animations that I put together in the first person, just record that action and play that back with different sets of digital human models to represent anything from the 5th percentile female from Southeast Asia to, let's say, the 95th percentile Scandinavian male, right? We've also integrated the ability to do full body tracking so that now, in addition to being able to visualize an entire car, right? That's a Volkswagen Passat in the background. That's somewhere in the order of 60 million polygons fully rendered. It's coming from 2 different CAD models. There's the CATIA data for the sheet metal and the body in white, and there's PTC Creo data for the drivetrain and the powertrain. And I can actually record myself interacting with that full model. And up until we had the power and the ability to import the entire CAD model and experience it in VR, we would have to have an engineer manually cull the data and only bring over the data that they thought mattered. But whenever I make a decision about leaving data out because I think it doesn't matter, I'm in fact greenwashing my engineering review, and I'm telling people that, oh, it's okay, I don't need to bring the whole car in, I just need part of the car to be with me. And then everything else I didn't import must be okay, right? It's going to work because I didn't bother to look at it and didn't bother to participate with it in the engineering review. And that would be a very, very costly oversight on our part if we try to take that vehicle to market and couldn't prove that we actually checked, can I build this operation? Can I remove that hydraulic cylinder from my steering mechanism? Other things that we're doing more recently, in this case, we're also taking the ability to do things in virtual reality when I don't have the engineering asset physically in front of me yet. I have to fully rely on VR to validate. In this case, this would be the disassembly sequence for this V8 engine, but you could think that the disassembly sequence is very similar to the assembly sequence. And what I'm finding out here is that if I don't take that exhaust manifold off first, I can't get that rocker cover out of the way, right? And so that means that in the assembly process, that head cover and that rocker cover should go in first, and then the manifold should go in later. And that would have been a costly mistake if I had done my process without this kind of validation. Now, my customers are always asking me, Eric, this is cool. You're in VR. What are you guys doing with AR? And my customers, right, my primary use case, I don't have the car yet. I don't have the engine yet. So I have to do everything virtual. But we've partnered up with a AR supplier, AR software provider called DIOTA. And DIOTA has this capability to take our digital assets that I can now save the state of the disassembly or the reassembly of those objects, and I can export those objects for direct use by augmented reality tools. Right? So DIOTA and us have partnered so that we can take these digital assets from VR, and now I can use them in AR, so that this is a view screen grab from a tablet-based AR device, where we are using the tablet tracking with a model of that V8 engine, and I can play back the sequence of installing those things that I proved the correct assembly sequence in VR. And this has always been a challenge for a lot of the people who are doing AR authoring for work instructions and such, because the normal workflow of creating AR digital assets is such a long and laborious task that sometimes they do that task parallel to the engineering validation of the assembly or service sequence. And sometimes they find that, hey, you made a really nice AR assembly document, but it turns out it's wrong. Right? It wasn't validated. And we want to use the same digital assets for validating our assembly sequence. Other interesting things that we're able to do in VR, and again, benefiting quite a bit from what we've learned from NVIDIA. This is a video I put together that I've actually played this video now for almost 2 full years. GTC Silicon Valley in 2017, I was rolling this video. I was doing collaborative VR downstairs in the exhibition area. The same time Jensen was talking about the innovation of holodeck, and I had to go around telling everybody, we're doing that already today. Right, so here you can see, yeah, that's me, right? So me with my beard doing some HMD assembly or service validation of this Volkswagen Passat. There's my colleague and his boss, and they're doing an engineering review in front of a large power wall. So we're able to do collaborative VR across different platforms, whether it's HMD to HMD, HMD to a power wall or a cave, or even HMD just to a desktop. Another mode of collaboration that we've been experimenting with and actually delivered to one of our customers, this is what you might think of as a augmented or a mixed reality use case. In this case, our customer at Jaguar Land Rover, they have a large motion capture room, and in that motion capture room, they've mounted some tracking targets to these Windows tablets, and in the middle of this room, it looks like it's empty, but apparently there's a dirt bike in the center of the room. And this guy's able to walk around that dirt bike, or now we're looking at a Jaguar Land Rover sport utility vehicle, and they're doing an engineering review of an empty room, but they're looking at the 3D digital assets. And we can have up to 8 different tablets walking around, each of them collecting and observing their own engineering insights into, is this a good design? Is this acceptable? And now they're able to do that work independently and collect all of their feedback into the 3D session so that they can do a group engineering review. As opposed to what many of you might be used to in a typical engineering review, one person driving the screen and the other person saying, let me look at the front of the car, let me look at the back of the car, let me look inside the car. These guys can all look at what matters independently to them. So what are we, those are the things that we've already done, right? So that's the present. What are we looking at as the possible future for the virtual reality and things that we're able to do, especially when you think about what Jensen announced on Tuesday or Monday with that whole idea of the RTX server, right? So imagine this as the RTX server. It's acting as a unified VR data center, where that VR data center, when necessary, can drive a whole bunch of people working on desktop, doing their day-to-day job to be done, virtual reviews of their product designs and of their process designs. Occasionally, that data center should be driving an immersive environment, a large power wall or a cave or a bunch of HMDs. But in the meantime, what if we could also send that out to a remote location where people are using those tracked tablets or HMDs or desktop installations, or really crazy over here, Mobile VR? Mobile HMD? Can we do that today? Right? Well, we propose that it's possible that if we were able to build this kind of infrastructure powered by the RTX server innovation, that we could in fact have this GPU going across the enterprise network and actually providing all of that rendering horsepower in the size that you needed it at the time. All right, so how do we get VR everywhere? This is a quick little video here, right as I'm running out of time, of a new project that we have called Verify.io. It is a little project that we're bootstrapping inside of ESI today. But what you might notice in this video, that's my cell phone. That's a Galaxy S7 cell phone. And I'm just streaming what you see here on my laptop, but that could be a server client or a server host. And I'm streaming that as a full 360 omnidirectional spherical view of the same CAD bodies without having to do any sort of minimization, optimization of the model. But that's in fact the full CAD model that I could now have streaming out to my cell phone or to my Daydream viewer. Questions, comments, snide remarks? I think I'm
Any
a minute
questions?
over.
Okay, let's give Eric a big round of applause.